Hi everyone, my name is Emily. Welcome to the IGE Day 2021 Computer Science activity. We're excited to have you join us even though we are online this year. Hopefully these activities are still going to be interesting and super fun. So I think to start off, we will introduce ourselves. I'll go first. So like I said, my name is Emily. I'm a junior at SIUE. I'm studying computer engineering, which is kind of a combination of computer science and electrical engineering. So I do a little bit of programming and a little bit of building actual circuits, which is pretty awesome. I really enjoy what I do. I'm also the vice president of the Society of Women Engineers. So I have been involved with IGE Day for the past 3 years, and it's been great. I'm really excited to participate again this year, and hopefully you guys will get a lot out of it. So I will hand this over to Daniel.
Hi guys, my name is Daniel. I'm a senior here at SIUE. My major is computer science, so I'm mostly focused just on creating and writing software rather than creating circuits or robotics. This is my second year with Introduce a Girl to Engineering Day, and my first one when it's been virtual, unfortunately. My favorite part of computers has always been getting them to do something useful for me. When I was in high school, I wrote programs to do my algebra homework for me, which was more effort than just doing the homework, but I did get the right answers out of it. And most recently, I've just been interested mostly in making small solutions for nonprofits. This year I'm doing my senior project and I'm building a new student attendance tracking software package for our foreign language training center. So that's a fun thing that when I'm done with it, it's going to be something that people use every day, hopefully forever. Not forever, but hopefully forever. Simran, if you'd like to go next.
Okay, this is my first year doing IGE Day, and I'm a freshman, and my name is Simran Patel. This is my first year doing computer science, majoring in computer science. So this year was pretty exciting, but at the same time not so exciting because of everything turning into online and stuff. However, I found a lot of excitement in writing my first code this year. I was so excited when it worked. So I like computer science because it allows me to write something and then see it unfold, and you just find a lot of happiness when something works. So I'll give it over to Mackenzie.
My name is Mackenzie. I am a sophomore. This is my second year at SIUE. This is my first IGE Day. I am a computer science major. I did computer science because I wanted to make a difference in the world and help people. And I realized with technology and computers being a huge part in everybody's life, I knew computer science was the way to go. And I enjoy it because I can create something new or solve an old problem and fill it with creativity and adaptability.
Awesome, thanks everybody. Like I said, we're really excited to have you guys here to try our activity, hopefully learn a little bit and have fun. So our activity today is going to be designing your own game. So before we begin, I would recommend you pause the video here and go find our instruction list, which should have been emailed to you. It's also posted on our Facebook page. That will be helpful if we go too fast, or if you just missed something, or if you'd like to do the activity again. And I'd also recommend you gather your materials ahead of time, just so it's easier to follow along. For this activity, you're going to need a piece of paper, either plain printer paper or colored construction paper, and then some art supplies. So markers, crayons, colored pencils, whatever you'd like. Those are the things that we recommend for creating your own game. So first up, the first instruction of the game is to spend a couple minutes brainstorming ideas for your game. So think about your favorite movies, favorite TV shows, video games, board games. You're going to want a fun, creative idea, but you're also going to want to be specific. That's a really common theme in computer science. When you're writing programs, you want to write fun things that are going to be useful to people, but you have to be very specific when you're telling the computer what to do, because it's only as smart as you make it. So you can go ahead and pause the video here and spend a few minutes brainstorming ideas, and we will be back. Okay, so now that you have an idea for your game, the second step is going to be designing the interface. An interface is the connection between the human users and a program or a game. So on your computer, the screen and the keyboard are interfaces. When you're playing a board game, the board and the pieces are the interfaces. So with the next few minutes, go ahead and pause the video again and take your sheet of paper and your art supplies and draw and design how you want the setting of your game to look. So whatever details you've thought of, whatever steps happen on people's turns in the game, draw those out however you want it to look. And then when you're ready, you can play the game, and we will show you what we've come up with and how we are going to demonstrate our game for you today.
So now that you have had your game and designed the interface of your game, now it is time for you to write the instructions. Make sure to be specific, because you want the players of your game to follow your instructions very clearly. And start from how the story of your game begins, and describe how to move along in the game, include different adventures or puzzles to solve, and talk about how to win. As always, make sure you are specific, because you would want the players to know what they're doing while they're playing the game. So take a couple of minutes to do that, and pause the video while you're doing it. So now gather the players that you want to play the game with. It could be your family, your friends, or your siblings, or whoever you would want to play the games with. Tell them and describe the story in the rules of the game, and be sure to show them your drawing and explain to them with the instructions that you've written in the previous step. If not, if they do not understand it, then you need to be more specific. Just like engineers have to be with computers, you have to tell the computer what to do, because the computer is not as smart as humans. So just like that, make sure you're detailing out every step so that the players know what to do and how to win. Once you explain your game rules to everyone, you guys can start playing and have fun.
Okay, guys, now we're going to show you kind of an example of what we did when we did this activity. We created basically a paper version of Tetris, which is what you see in front of you. We have the playing board. We have an user interface over here that will show the player what piece is coming next, what level they're playing at, how many lines of blocks they've cleared, and what their score is so far. The way it works is Emily, who's going to be playing the game, has an user interface down here where she can tell me, the computer, to move pieces left or right, to make them go down quicker, or to make them go all the way down as quickly as possible. She can also rotate pieces clockwise and counterclockwise. And she gets to do one command for every tick of the game. And each tick, the normal Tetris rules kick in. Each tick, the piece will be forced to go down one piece. If it gets to the bottom, then on the next kick, the next piece will appear at the top, and she'll keep going from there. And we're basically just going to play until she clears one single line. So by following the instructions that I wrote out for the game, first I initialize the game. What I do is I roll an 8-sided die, and that gives me a 6. And I look at my instructions, and I see that a 6 corresponds to a green piece. So I'll put that in the next slot. And then the instructions tell me to start the game. And that means I roll again to get another piece. I get a 7, which asks for a red piece, and I put the green piece at the top. And then this is the first tick. So Emily gets to tell me what command she would like.
I would like to move 1 cube left.
Which is my right. There we go. All right, and then I'll do another tick. The instructions tell me I move the piece down 1, and then we start over. Emily can issue me a command.
I will go left again.
Tick,
Left again,
tick,
and left one more time.
tick.
Now I will do a hard drop all the way to the bottom.
And then the instructions tell me to bring the new piece to the top of the board. Roll the die. I get a 4, which I decided an orange piece is going to be next. And it's a tick, and Emily can tell me what to do.
And all the way down.
All right, so I just rolled an 8 on the die, and this is where my instructions really kick in, because there are actually only 7 different Tetris shapes. So I wrote in my program that if I roll an 8 on the die, I just throw it away and roll again until I get something that's not an 8. Here I got a 1, which is a light blue piece. All right, ready?
And all the way down for a complete row.
All right, and now Emily has completed a line all the way across at this third row. So what would happen at this point is I would have to delete all of these squares and then move the ones that are above down 1, which would involve me cutting my pieces into half pieces. We're not going to spend the time to do all that, but we could do that. I could, cut these pieces in and print out as many of them as I needed, and we could play possibly an entire game by the end of tomorrow. But that gives you an idea of how you can create a paper prototype of a game and follow your written instructions to see how it works.
So I'm going to show you a demo of some code that I wrote. So first we're going to see a very well-known code that every computer scientist knows. I'm going to show it to you in different programming languages, and you're going to be able to see the differences in each of them. I know there's a lot of programs out there that you can download to write code, but if you're new to computer science, I recommend this website. It is called onlinegdb.com, and it stands for GNU Debugger. Debugging is a process that helps you remove errors or bugs that you find in your program. I also recommend Visual Studio and BlueJ if you're just starting out with coding and you want to use a program. So let's get started. So this one here is, I believe it's in language C. So if you go over here, you can find all the different languages that you'll be able to write in. So here we have C++. And then we also have Java, which is the first programming language that I started out with. So if we click here, you can run the program, and it's going to print your statement out here. And basically, it's a very simple statement, and it's going to print hello world. You can also change it to say, you can go up here and say, hello, my name is Mackenzie. And you can go ahead and run it, and it'll print it out. What I'm going to show you is a very fun game that your computer will play with you. I can print it out I can show you it and you can write it yourselves. So I'm going to go ahead and run it. And so this will be, the lower bound is, let's say 0, and then my upper bound is going to be 10. So now my computer is going to give me three chances to guess the number. So let's say I guess the number 5. It's too small, so now I got to guess 7 and maybe 9. I got it. So I'm going to show you guys this code, and you can go and write it yourselves and play around with it. So here you go.
So what you've done in this activity is similar to how programmers create software. By composing descriptions of objects and arranging sets of instructions about what to do with them, programmers lay out in code exactly what a computer should do, from interpreting commands from a human user to performing useful computations to displaying results on a screen or through a speaker. This forms the basis of creating all kinds of software, be they video games, web browsers, airplane autopilots, instant messaging apps, or anything else. Now, besides implementing a program, programmers also have to think about its user interface, what users see when they use the software, and how they tell it what to do. Programmers have to learn to see things from the point of view of the users, keeping in mind that users often don't know how the software works and may have no one to teach them how to use it. Decisions about how buttons and menus and other controls are laid out and what words appear on them can make the difference between a program that people want to use and a program that they don't. So to figure out what code is needed for a program, programmers have to carefully think through their vision and their goal, breaking problems down into smaller problems that can be solved one at a time. Many programmers spend a lot of time planning and making diagrams or paper models to help them keep track of details. And sometimes they might have to experiment with code to see if one approach or another approach works better for them. Sometimes they throw away code and decide that this particular code, even though it technically worked, didn't do what they really wanted, and they would like to use code that's organized a different way. If you're interested in learning more and actually doing some programming of your own, there's all sorts of places you can start. Here are some of them. First, Scratch is a programming language created by the Massachusetts Institute of Technology specifically to teach programming to people from ages 8 to 16. Scratch works right inside your web browser, so you don't have to install any software to get started, and it has tutorials to teach you if you like. However, if you don't have to use something kid-friendly if you don't want to. Lots of young people get started with programming just by using normal programming languages and tools and following tutorials and asking questions online and reading books. One great option is the Godot game engine, which can be used to make both 2D and 3D games of any kind. Godot is free and open source, so you don't need any money to use it, and its website includes tutorials aimed at beginners of every age. Godot comes with its own code editor and a programming language, Godot script, but it can also integrate with some other popular programming languages like C# that are used by professional game developers. If you want to get started with other programming languages, you'll want a serious code editor that provides you with the bread and butter tools that every programmer uses. The most popular option today is Microsoft Visual Studio Code, which is free and open source and runs on Mac, Windows, and Linux. If you have a Mac, you should also look at Apple's own Xcode editor, made specifically for helping programmers to make Mac and iOS software. Finally, there are lots of tabletop games and video games that teach programming skills. Tabletop games like Robo Rally, Mechs vs. Minions, Robot Turtles, and Codemaster teach some programming skills and ways of thinking while you have fun with family and friends. If you feel more like spending time on your own, then check out video games like Space Chem, Opus Magnum, and Factorio, all games which teach important problem-solving skills and techniques. All right, So that's everything we have. We hope you enjoyed this activity. We hope you're interested in learning more about programming. If you look in the description below for this video, you'll find links to all sorts of stuff that we talked about throughout this video, and you can get started right down there. Thank you so much, guys. Have a good day.